guys, this is Miss Brown speaking, and today we're going to talk about scaling to create equivalent ratios. You may be wondering what scaling is. So, a definition is that scaling is the process of multiplying the numerator and the denominator by the same factor to produce equivalent ratios. If you don't know what a ratio is, the technical definition of a ratio is a comparison of two numbers using division, but the non-technical definition of a ratio is just a fraction. So anytime you hear me talking about a ratio, I'm just talking about a fraction. So let's give an example. If I ask you, or if I give you the fraction or ratio 3/4, and I want to know 3/4 is equivalent to what number, and I'm just going to use a dotted box to represent my number in question, over 8. Most of you can automatically tell me what number you would put in that box. For those of you who might be struggling a little bit, what we're going to end up doing is looking for relationships between numbers. The relationship can be horizontal, going from left to right, or right to left. The relationship can also be vertical, going up and down, or from down up. So I'm looking and I notice that I can easily find a connection between this number 4 and that number 8. Notice I'm going from the 4 to the 8. So let me ask you, what number can I multiply 4 by to get 8? You're right, it is 2. 4 times 2 is 8. So basically, what I've done to the denominators, I've multiplied 4 by 2 to get 8. I'm going to also do the same thing in the numerators, going in the same direction. Notice I'm going from the 3 to my empty box. You want to concentrate on going from what you do not You want to concentrate on going from what you do know to what you don't know. That's why I'm going in that direction. I do know the number 3, but I don't know what goes in that box. So I want to go in the direction towards the number I do not know. Anyway, just like I multiplied by 2 on the bottom, I'm going to multiply by 2 on the top. And 3 times 2 is equal to 6. So we've got our answer. 3/4 is equivalent to 6/8. And you might be wondering, well, what do you mean by 3/4 is equivalent to 6/8? Those look like different numbers to me. I can prove that in several ways. One way I'm going to prove it is with division. So I hope that you guys know that the fraction 3/4 can be rewritten in the following fashion. 3 divided by 4. And likewise, the fraction 6/8 can be rewritten 6 divided by 8. So I'm actually going to do that division. I'm going to do, on my left-hand side, 3 divided by 4. I'm going to draw my little house, and the 3 is going to go on the inside of the house because it is the numerator, and the 4 is going to go on the outside because it is the denominator. 4 cannot go into 3. So I'm going to put a 0. I'm going to add a decimal, bring the decimal up, add another 0, and 4 can go into 30 7 times. And 7 times 4 is 28. I'm going to subtract out. That gives me 2. I'm going to add or annex a 0 and bring that 0 straight down. And then 4 can go into 20 5 times. 5 times 4 is 20. And when I subtract out, I have 0. Okay, so basically 3/4 is the same thing as 3 divided by 4 is the same thing as decimal 7/5. Let's go on the right-hand side of our screen to 6/8, which is 6 divided by 8. And I'm going to do that division as well. I'm going to draw my house. I'm going to put a 6 on the inside because it is the numerator. And I'm going to put the 8 on the outside because it is the denominator. 8 cannot go into 6, so I'm going to put 0. I'm going to add a decimal, bring the decimal up, add 0. 8 can go into 60 7 times. And 7 times 8 is 56. I'm going to subtract out. 60 minus 56 is 4. I need to add or annex another 0, bring it straight down. 8 can go into 40 5 times. 5 times 8 is 40. Subtract out, and I'm at 0. So we've pretty well figured out that 6/8 is equal to 6 divided by 8, which is the same thing as the decimal 0.75. So let's go back to what I was initially talking about. What I mean by their equivalent. Even though the numbers look different, 3/4 looks different from 6/8, notice when I do the division, in both cases, I come out with decimal 7/5. There's also another way to think about this. Let's just go back to, say, maybe third grade or fourth grade when we first started learning about fractions and we actually drew pictures. So I'm going to draw a picture and represent the fraction 3/4. Give me just 1 second. Okay. All right, let's try that again. Okay, so I'm going to represent the fraction 3/4. So what I'm going to do is I'm going to draw a shape, and I'm going to divide it into 4 equal sections. Okay, so 3/4 literally means that I have 3 sections. That's 1, 2, 3 sections out of 4. Well, let's look at 6/8. So I am going to draw a box the same size as my box on the left. But this time, instead of dividing it into 4 equal sections, I need to divide it into 8 equal sections. So alrighty, almost there. If you notice, my box is now divided into 8 equal sections. And this time I'm going to color 6 sections out of 8. So here is 1 section, 2 sections, 3 sections, 4 sections, 5 sections, and 6 sections out of 8. Now, if you look at my drawing on the left-hand side of the screen, right here, and if you look at the drawing on the right-hand side of the screen, right there, if you notice, I have shaded the same area yellow. So that's another way visually to understand that 3/4 and 6/8 are equivalent. I'm going to end this video here. In the next video, we will talk more about scaling to create equivalent fractions.